So, welcome to the fifth class of quantum mechanics, where we will study about the dual particle wave particle duality. That is the dual nature of wave and light. So, in classical mechanics, waves and particles are two completely distinct physical entities. Waves extend continuously in certain region of space, whereas particles are discrete and have little or no spatial extent, as we have seen in the diagram. This is represented by a particle and this is represented by a wave. So a particle is specified by its mass, velocity, momentum and energy, whereas the wave is specified by its frequency, wavelength, phase or wave velocity, amplitude and intensity. But in quantum mechanics, waves sometimes act as a particle and particles sometimes act as a wave. This strange behavior where waves are seen to exhibit particle-like properties and particle exhibit wave-like properties, and this double nature of the particle wave is known as the wave particle duality or dual nature of light, as we know that the light is also a wave. So light possesses a dual nature, that is both wave and particle nature. So what where we found that this is the wave nature of light. So the phenomena such as diffraction, interference, and polarization, they these phenomena are totally explained by the wave nature of light. Whereas the particle nature of light, the phenomena such as photoelectric effect, black body radiation, and Compton effect, these are explained with the help of particle nature of light. So, on the basis of this dual nature of light, in 1924, Louis de Broglie proposed that all material particles shows uh, dual character. Dual character. Okay. So his concept about the dual nature of wave is based on two observations. The first observation is matters have symmetry just as radiation, and the dual nature matter should have possesses dual character. So that means matters have symmetry and matter should also possess dual character. Matter should also possesses dual character. And the second observation is that the whole universe is composed of whole universe is composed of matter and electromagnetic radiation. Electromagnetic radiation. So, and both should be symmetry, and both should be symmetry. Okay. So, the wave associated with the moving particles is called matter wave or de Broglie wave. Wave associated with moving particle is called matter wave, or we can say de Broglie wave. And the wavelength, he gave the result of the wavelength associated with a material particle, a material particle is given by lambda, and this lambda is equal to h by p, where h is the Planck's constant and p is the momentum of the particle. As we know that the momentum is equal to m into v, where v is the velocity of the material particle, so and the m is the mass of the particle. So this is the de Broglie hypothesis. We can, this equation is called, if we take it equation number 1, this equation defines the de Broglie hypothesis. So matter waves are associated only with the particles moving with the finite velocity. Now this equation of de Broglie wavelength have some different um, expressions in the different terms, if we change some terms with respect to relativistics and other phenomena, we can represent this in different forms also. So we will derive it here. So if capital E is the kinetic energy of the material particle, so we, as we know that P is equal to root over 2me, we can derive it here, as we know that if E is the kinetic energy of material particle, this is half mv square. So if this can be written as m square v square multiplied uh, denominator and numerator by m. So we can write is m square v square, we can write p square divided by 2m. So here p square is equal to 2me. So from this we have equation p is equal to root over 2me. So therefore equation 1, from equation 1 we have lambda is equal to h by p, or we can write h divided by, in place of p we can write it as 2me. This is equation number 2. Now next, in terms of charge carrying particle, so if a charge particle, carrying charge small q in accelerated through a potential difference v volt, then the kinetic energy, that is capital E, is written as q into v. Therefore in this case lambda is equal to h divided by root over 2m. In place of E we can write q into v. This is equation number 3. So these are the different forms of the de Broglie wavelength. First one is lambda is equal to h by p, h divided by mb. Second one is h divided by root over 2me. Third one is h divided by root over 2m q v. Okay, if material particle is in thermal equilibrium, if material particle in thermal equilibrium, then from Maxwell's distribution law, the kinetic energy is given by k into t. where k is the Boltzmann constant. Boltzmann constant whose value is fixed, that is 1.38 into 10 to the power minus 23 joule per Kelvin. So therefore in this case lambda is equal to h divided by root over 2m. In place of e we can write it as k into t. This is the fourth equation of the de Broglie wavelength. Okay, so these are the four equation of de Broglie wavelength, and this is the all about the dual nature of light. So in the next class we will see something about the de Broglie wavelength and some its expression for the relativistic conditions, and then we'll see about Compton effect, and then we'll start the wave mechanics with derivation of Schrodinger second order differential equation and its solutions and another terms related to it.